All right, so these ones writing in simplest form, we have to apply these properties of exponents that we've learned. And we're applying them specifically to the rational exponents. That just means there's fractions. The main properties are that if you multiply two exponents together, fractions or not, it doesn't matter, then you add those powers together. Also, if you're dividing two exponents with the same base, you subtract them, and it's always the top minus the bottom. And then if you have something, an exponent that's got a power already, and you give it another power, then you're going to multiply those two powers together. And finally, if you have a negative power, fraction or not, it doesn't matter, that turns into a fraction where it jumps the line and changes the sign. So first one right here, we've got x to the 2/7 times x to the 3/14. We're going to combine those together, and you have to add those powers in order to make them work. So then that's going to be, let's see, that's 7/14 or 1/2. So our final answer is x to the 1/2. Okay, next one, same idea. We've got two exponents that are being multiplied together, so we need to take and combine them into one by adding their powers. Now, you can use a calculator on these. It's not a big deal. You just need to leave your answer as a fraction in the end. So when you go boop, 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 calculator says you end up with 9/2, not 4.5, 9/2, right? Yeah, do not ever put a decimal up in the power. You'll get it completely wrong. Okay, this time we are dividing. Property says to divide, you're going to subtract those powers. So it's going to become x to the 2 minus 1/4. And again, calculator, boop, boop, boop. Calculator says that's going to be x to the 7/4. Right, we're multiplying, which means we need to add those powers together. That's 3/7 plus 5/14. I think that's almost the exact same problem. Okay, that's going to end up being y. These two added together, that's 11/14. And that's it. Forgot to circle. Okay, let's go with this next one. This one you have an exponent and then it's raised to a second power. In that case, you're going to take those powers, -4/5, and multiply them together. When you multiply those, the 5's end up canceling. You get x to the -4, but you cannot leave negative powers, so instead you write it as a fraction, and that 4 becomes a +4 on the bottom. Okay, same idea for this next one. Exponent raised to a second power means we multiply powers together. That becomes x to the -2 or 1/x squared. All right, now we're going to solve some radical equations. Now, solving radical equations just has a couple steps. First of all, you have to get the radical alone. Get the radical alone. Now, if you remember, that means anything that's not underneath the radical needs to be moved to the other side. So you might have to add or subtract something, and then you might have to divide by a number out in front. And it might not need to. It might already be set up that way. Okay, then you put parentheses and a power on both sides. And this power is going to be the same as the number on the shelf, because that will cancel. The power and the radical will cancel. Okay, and then you're going to finish solving. 4x All right, let's look at a couple of these. So number 7 here, we've got square root of 6 minus 3x minus 2. That 2 can't be there, so we've got to get rid of it. I'm going to add 2 to both sides. 6 minus 3x equals 2. Now I can get rid of the radical. And I'm going to do that by putting parentheses both sides. Since this is square root, the number on the shelf is 2, which means the power is going to be a 2. Those cancel each other, and it just leaves 6 minus 3x here. And this side is now 4. Then we're going to finish solving. 6 minus 3x equals 4. Minus 6 to get rid of it. Cancels. Negative 3x equals negative 2. Divide by the negative 3 because it's multiplying by the x. And we get x equals 2/3. Okay, this next one. Now these were the special ones. Notice how there's a radical on both sides. If I were to raise this one to the shelf power and do the same to this side, they both have it. So basically those radicals just drop off. And you get 2x minus 5 equals x. I'm going to move these x's over to here. I get negative 5 equals negative 1x, or I'm going to divide by negative 1 to make that a positive x. You end up with x equals 5. Oh, look, same thing. They have the same radicals, so basically they just cancel, drop off. X plus 3 equals 2x plus 1. I'm going to subtract 1, get rid of that. Got to get the x's on both sides, or on the same side, so I'm going to get rid of that one. That becomes 1x equals 2. All right, this one, that is a 2 out on the shelf, so we're going to put a 2 on there. But whatever you do to one side, you have to do to the other. So squared, so that cancels. So we have 2x minus 5 equals 49. Add the 5. 2x equals 54. Divide to get rid of that 2. And you get x equals 27. Now these ones look a little bit different because they've actually got a fractional power. So this isn't a radical, but technically it's the same step still. You got to get that thing alone, okay? That thing raised to the power is alone. And then you're still going to take and raise both sides to a power. You're still going to put parentheses on there on both sides, right? Parentheses, parentheses. But instead of just the shelf number, you just do the reciprocal. Because now these powers cancel each other out. And this side is 2x plus 4 equals this stuff, right? 16 to the 3/4. Boop, boop, boop. Calculator says that's actually 8. And then you're going to finish solving. 2x equals 4. Dividing by 2 to cancel. This becomes x equals 2. Okay, so this next one, same idea, except for look, we've got this 3 out in front of here. In order to get rid of that 3, it's 3 times that stuff. Divide by it. Turns it into x plus 3 to the 3/4 equals 27. Now we can get rid of that power by putting parentheses, both sides, and doing a power that's the reciprocal. The reciprocal is how you cancel those fractional powers. So breaking it down, we've got x plus 3 equals, calculator says that's 81. And we're finished solving by subtracting 3, and we get x equals 78. Okay, these ones, again, fractional powers, they have to be alone. So I'm going to add 4 to both sides. And I get x to the 2/3 equals 25. Now I can get rid of that fractional power. by putting parentheses around both and doing the reciprocal of 2/3 on both sides so that that will cancel. I'm left with just x over here. Boop, boop, boop. Calculator says that's 125. Right? Very similar example. Subtract a 3. Oh, look, it's the exact same thing. Why'd I put the same thing on there? Fraction, blah, blah, blah. Yeah, same thing. My bad. Oopsie. Okay, let's do transformations then. So list of possible transformations. Again, it's the same idea. You can go left or right, up or down. You can reflect over the x-axis or y-axis. And you can also do a vertical, stretch, or shrink. And again, you have the little cheat sheet to help you remember how to figure these ones out. But for the most part, you should know them by now, hopefully. The key is knowing what's inside and what's outside. So for these guys, underneath the radical is going to be your inside. Whoa, we don't want that. Who touched that? That's not at all what I wanted. So inside means under the radical. Remember, in your cheat sheet, it's got horizontal inside, vertical outside. That's all you have to remember. Okay, here's the original. Here's the new one. We've got 3 changes. We've got this negative out in front. We've got this +5 inside and this -2 outside. So negatives, when you throw a negative inside there and it's outside, that means it's a reflection over the x-axis. Let me write down the pieces, what you look for in your table. So this is a negative outside, which means a reflection over the x-axis. Okay, this next one right here, that is adding 5 inside. Okay, go to your little cheat sheet table, and that means that this has been moved left 5. This one, we are subtracting outside. Cheat sheet table says that that's actually down 2. Okay, had to save a little bit of time, so I went through and put all the changes and described them. This one is multiplying outside by 4, which means it's going to be a vertical, either stretch or shrink. Since 4 is bigger than 1, it's going to be a stretch by 4. Adding outside means we're moving up 3. Subtracting inside, table says that's right 2. Adding outside would be up 2 again. Okay, negative outside means a reflection over the x-axis. Multiplying outside means a vertical either stretch or shrink. Now it's a 1/2, which is a smaller number, so it's going to be a vertical shrink by 1/2. And then adding inside means we've moved left 4.